Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all of you. For this academic session this semester, we have only 2 weeks left. This week and the other one is next week. Okay, and so for this week, we will introduce you about the DC motor and also DC generator. But I think we are not able to cover much, okay, due to the time constraint. So meaning that for this semester, so for this title, DC machine and AC machine, so I will just focus on uh, the topic, the subtopic that will be in your final exam. Okay. So just I hope you have already watched the video, especially on the first one, which is the 3D animation, which briefly explained about the theoretical or the principle, the working principle of the DC motor itself. Okay, so I hope you have already watched that. But if you haven't yet, it's okay. So, but please watch that, because from that you can have the general overview about this DC machine. Okay, so my focus here by today is just to summarize the theoretical part, okay, and highlighting something that I think that information need to be known by you, okay, by the students. And then we will finish this class with one example from the notes, and the solution is also I have already shared with you in the WhatsApp group. So for today, we will finish on the the shunt, okay, the shunt motor and so on. So on Wednesday, inshallah, so we will go on I think a very small topic, small subtopic, which is the control of the DC motor. Okay, so as you can see here, this one we have what we call a machine. Okay, and this machine can be the generator, and also it can be also a motor. So generator meaning that it supplies the power, okay, supplies the power to the load. Okay, so and then this machine also can be also operated as a motor, meaning that it is a load, so it absorb power. So meaning that generator is actually from mechanical power, mechanical energy into electrical energy, okay, such as the hydroelectric pump and so on. And motor meaning that it use electrical energy and then convert into a mechanical. Okay, and for this machine, we have what we call DC machine and also AC machine. Okay, so DC machine meaning that it use DC power, and for AC machine meaning that it use AC power. Okay, so the working principle, even though it is just the different is actually in terms of the power supply, but actually the structure, the structure is the same, stator and rotor, but the principle, the working principle is actually a very different compared from DC to AC machine. So right now, this today, so I just give you a brief what is DC machine and what is actually more towards on the motor lah, okay? More towards on the DC motor and also AC motor. Okay, guys, can you name it? Okay, can you just give me what type of motor that used for our um, home fan. What is the type of the motor? What is the type of the motor? Can someone give me the answer? DC motor. Okay, one of your friends said that is use a DC motor for the fan, fan. Oh, okay. Next semester is still online. I don't know. I don't know. So it depends on the KPT, our ministry, and also our university. So right now, they haven't decided yet. Um, okay. So one of your friends say AC motor, one or okay, and they are also said about the DC motor, brushless motor, AC induction motor, DC. Oh, okay, okay. Okay, so AC motor is and also DC motor is a general, it's actually a group. Actually, under AC motor, for okay, we have induction motor. Induction motor, we have synchronous motor, and so on. But it's okay. You if you haven't known this, but this is actually inside your slides. Okay, but if you haven't known this, then still okay because no need to worry about this. Okay, so induction motor and also synchronous motor, and under this we have single phase motor and also the motor yet that use a three phase supply. Okay, and for the DC motor, yeah, we have a permanent magnet. We have magnetic. There are several types. Okay, so I don't want to name it. Okay, so home fan. Some of you AC motor. So it's quite general. AC motor. DC motor is quite also general. So actually, for your information, your fan, your ceiling fan at home, use induction motor. Okay. But what type of induction motor? Which one? Single phase or three phase? Yes, of course lah, single phase, right? Must be single phase because your plug, okay, you have three pin, right? This one is for earth. This one is your for life. And this one is neutral. So just bear in mind that for the transmission line, we have three wires. We have phase A, B, and C, and neutral cables. Okay, and usually for a house, a row of house terrace, okay, terrace A, terrace B. So only one phase will go into, okay. So this one may, and when this line may be phase B and the neutral point. Okay. So meaning that actually all your home appliance use single phase. Okay, use single phase. So your fan is actually a single phase induction motor. Okay, but okay, and then your air conditioner, what type of motor? What type of motor, and is it a single phase or three phase? Air conditioner. Yeah, single phase. Single phase DC motor or AC motor? Yeah, for the actually for the aircon, okay, please don't get confused because for the aircon we have, okay, sorry for my bad drawing. Okay, so this is what we call indoor unit. Okay, aircon usually we have two separate units. We have, and then another one is actually the one is actually outdoor unit. Okay. So inside this indoor unit, there is nothing. There is no motor. Okay, there is no motor. The motor that only consists inside this indoor unit is actually just is actually a blower, a motor blower. Okay, just to blow the air. Okay, uh, to the surrounding. The motor, the AC motor that is actually inside this aircon system is actually under outdoor unit. So it is installed at the outdoor unit. So I think you have heard about the units of this one is actually inside this outdoor unit we have compressor. Okay, so the compressor is actually a motor that rotate so to compress the air. Okay, so that the air will become cold and so on. So when your aircon is not cold enough, so there is something wrong on your motor compressor. Okay, so compressor is the very um, essential item here. Hold on, okay, I have someone coming in. Okay, sorry for that. So the compressor is the motor. So the compressor is actually your single phase induction motor. Okay. Okay. So but you will actually heard about the fan and air conditioner, which is saying about for example home fan. It is actually DC fan, and then for the air conditioner, maybe you heard about DC inverter and so on. So it's quite confusing. So is it DC fan? For example, if you are the new fan, the new type of fan, for the ceiling fan, they say that this is a DC fan, much more quieter, much more lighter, and more efficient. So is it DC fan here is a DC motor? Yes, they said it is energy saving by using DC fan. So, but right now, is it truly a DC motor? And meaning that for the DC inverter for the air conditioner, is it truly the motor used for the compressor? Is it a DC motor? Okay. Can I ask you what type of the motor that used for the drone? We have the quadcopter, right? We have, for example, lah, this one. This one you have a blade, right? Blade. Right now is very famous right now, the quadcopter or drone. What type of motor that use inside this? DC. Okay, some of you said it is a DC motor. Okay, so I think majority of you. Okay, so one of you said DC brushless motor. Okay, so DC, so no AC. Okay, okay, DC. Okay, so for the drone, they use DC. Yes, your what your friend said, one of your friends said is true, correct. This brushless DC motor. So actually, all these fan, for example, DC fan, it is actually what we call bukan brush, DC brushless. We call this one is a brushless DC motor. In other words, it's actually BLDC motor. Okay, in the short form is a BLDC motor. Meaning that actually this DC fan is a BLDC. This is also BLDC. Okay, but it is not DC motor. Okay, this BLDC motor is actually an AC motor. So it is under AC machine. Okay, it is actually an AC motor. The name only because actually the physical, the operating principle is same with the DC motor. Okay, but actually that one is actually AC motor. Okay, so please don't be confused. So maybe someone approach you that I sell DC fan, smart, quieter, efficient, and very so on. So actually the drones here use BLDC motor, and this one is actually an AC motor. Okay, it is actually an AC motor. So actually BLDC is a new generation of AC motor. It's very compact. Okay, the structure is also very simple. Since the structure is very simple, so meaning that the losses is very minimum, meaning that the efficiency is very high, and it is also a very cheap. Okay, the electrical scooter or the electric bicycle, electric bike, for example, electric bike, bicycle. So you install here, you have a motor here, install at the rim, inside the rim, okay, and then so it will actually run your bike, okay. So the motor installed here, so this one you have a battery installed here, so this is your battery, and your battery is a DC supply, right? DC battery, and this one, the motor here is what you call, is actually a BLDC motor. And one of our friend asked me, why this is a AC motor, but because the supply is DC, right? So it's not match. Okay, but if you look carefully inside that system, so we have the battery, okay, and then we have the motor, BLDC motor, so it is require AC, so this one output DC, so they are a system where a power conversion is done. This is where we call inverter. That's why for the aircon, you see that some of the, for example, Panasonic or something, they sell their air conditioner as a DC inverter motor, right? Because it use inverter to convert from the DC supply into an AC power to supply the BLDC motor. Okay. So this is inverter, which is a new technology, which is under my expertise, where we design the circuit, how to convert from DC power into an AC power. Okay, so please note that on that, this is also a new technology, BLDC motor and so on. So actually, for the drone, so the battery is DC, but this one is AC, so actually you need some conversion there. So the air conditioner, so it depends. For the air conditioner, mostly they are induction motor, mostly. Okay, but for the higher end air conditioner, meaning that the modern, so some of them use what you call the DC inverter, meaning that it use a BLDC. Okay, so aircon use, some of them use what you call conventional aircon, and one of also use BLDC. Okay, please be not confused. I think you have confused. They are different. Okay, DC inverter, aircon that labeled as a DC inverter, so it use inverter plus BLDC motor. They are also aircon that come only with this one, with this not name, inverter only. So meaning that it use only inverter plus the AC motor induction AC motor. Okay, but yeah, I cannot elaborate this one. This one is a little bit complicated here. Okay, but what I want to highlight is actually on this BLDC motor. So just to, if your friend that maybe dekat kampung on your at your village ask you whether what type of motor here. So I hope you can answer. Okay, you can answer that. Okay, because BLDC motor is very compact. This is a new technology. It's very compact. If you compare to the induction motor, okay, induction motor, the size is very big. If you want to install here, so the size is very big and is also very bulky and the berat lah. Okay, if kalau saya cakap dia terlalu berat, so tak sesuai. Okay, that's why we are using BLDC for a drone. Okay, for a drone and so on. So it's quite okay. Yes, quite heavy if you want to install induction motor here. So that's why we use a BLDC motor. Yes, the inverter motor will save more energy. Okay, if you have inverter and then plus with this BLDC motor, you have, I think, efficiency you will achieve. You will also achieve in terms of the volume, the size. You will have a very lightweight size and so on. Okay. Okay, one more. I think one last thing lah. I just want to know your knowledge. What is the motor install inside your blender? Blender ni bukannya ni kadang orang kata apa? Blender tu yang your yeah, you know, inside the kitchen blender. What type of the motor installed in the blender? Orang perempuan, the woman should know this. What type of motor installed inside your blender? AC motor, okay. Induction motor, single phase, should be single phase, okay. Okay, single phase induction motor. Okay, any other answer? DC motor? Okay. All are wrong. All the answer that you give is wrong. Okay. One of your friends said that your friend here said it is a universal blender. Yes. How did you know? Nabila, how did you know? The blender here is a universal motor which is not covered inside this course. Okay, universal motor. Blender is a universal motor, meaning that it can supply, it can DC power supply can, AC power supply also can. So meaning that if you want, if not, if you are not convinced yet, so please supply with a battery. So you will see that your blender will also working. Okay. So universal motor meaning that it can be supplied both, either both DC or AC. Okay. Vacuum cleaner is depends on the manufacturer. For the Dyson vacuum cleaner, Dyson, you know Dyson, the lightweight and so on. So you just very handy and so on. So they use a BLDC. They use a BLDC motor inside. Okay, because they want to achieve the lightweight. The objective of their product is a very lightweight and efficient. Okay, 30 minutes on that. Okay, so okay, we go for the structure. So I think yang lain-lain tu the others for the other information you can just refer to my videos. Okay, so I just want to highlight 1 point or 2 point from the slide. Okay, so for the motor, we have two structure. We have what call this one is a stator. Okay, and then we have what you call this one is inside this one is actually what you call a rotor. Okay, we have a multiple winding. This one is a rotor, so this one will actually rotate. Okay, okay, and this one is supplied by a DC source. Okay, DC source. So and then this is what you call, we have a commutator here, brushes. Okay, brushes. Okay, this one we call brush, where this one is they contact this the armature and so on. So this one is a brush. So for the DC motor, it has brush. For the AC motor, we don't have brush. So that's why we have what we call BLDC. Okay, this AC actually an AC motor, but the principle is actually same with the DC motor, but it is the physical, there is no brush, so that's why the name come be the brushless DC motor. It is actually an AC motor. Okay, so it depends on, so this one, if you look, we have a stator and then we need to have a pole, right? We need to have a north pole, the mau cakap apa, dia punya north and south, right, to produce flux, right, to produce flux. Saya tak tahu nak pakai color apa lagi ni, colorful lah. Okay, this one, to produce flux. So flux will okay, flux will flow from north to south, right? And it depends. It depends. Okay, hold on. I have another, I think maybe important. So hold on. There's a call here. Okay, hold on. Okay, hold on. 1 minute, okay? Okay, sorry for that. This week and next week is a very busy time for the lecturers because we have a lot of presentation, the master student presentation, the final year project presentation, capstone project presentation, and so on. Okay, so sorry for that. So let's continue. Okay, so we have also another north and south pole here. And then north and south, so we have yeah, it's the flux. Okay, so we have maybe this one what you call 4 poles. Okay, and in order to produce this magnet, okay, which is we can have this to be the stator to be what we call permanent magnet. Okay, the stator is itself is the permanent magnet. So that's why we have permanent magnet DC motor, which is PMDC motor. Okay, meaning that it is a very heavy because the magnet itself is very heavy. Okay, so the stator itself is the magnet inside this, a permanent magnet. But there are also type of DC motor that did not use permanent magnet. Can someone just elaborate for me? They didn't use the permanent magnet because it is very heavy. So how to produce this north and south pole here to produce the flux? How? We have learned during our, yes, from our second topic, the electromagnetic. So we produce magnet from the electricity. Okay. So what we can do is actually we winding. We have a winding. Okay. This one also must be wind, and then we have another supply. Okay. So this is what we call this one. The circuit that used to produce the flux is what we call, what is it? What circuit is this? Field circuit. And this circuit that connected to the the rotating plate is what we call armature circuit. Okay, so these two circuit is very important, the field circuit and armature circuit. So I hope you know when we talk about field circuit, you can imagine what is actually this circuit represent in the physical form. Okay, so field circuit is actually a circuit that used to produce the flux at the stator. Okay, and it depends. So this motor, as maybe if you refer to my slide, this DC motor, we have permanent magnet, right? Permanent magnet DC motor, and we have what I call field winding DC motor. Okay, so under this field winding DC motor, we have shunt DC motor. We have a series DC motor type, and we have compound, and another one is separately excited DC motor. Actually, a separated excited DC motor is actually similar with the shunt motor. It is same, okay, in terms of their performance and so on. So shunt DC motor is actually what we call, is another word, is actually parallel. I don't know the spelling whether it is correct or not. Parallel DC motor. Okay. So what is a parallel DC motor? What is the series DC motor? So it actually depend on how the field circuit and also your armature circuit is connected. Okay. So meaning that for this parallel motor, for parallel DC motor or shunt DC motor, meaning that this one, your field circuit and your armature circuit share the same source, and then it is connected parallel. Okay, positive, negative. Okay. While for series, meaning that your field circuit and armature circuit are connected in series. Okay, so meaning that if I draw my circuit, I have this one is my voltage supply, and then the field circuit can be represent as a RF. Can be represent as we have RF field. F is represent field and also inductor. Okay, and then we have RA and also LA, and we have this one we call EA. EA is actually back EMF. Okay, so it is a voltage. It will produce a voltage. Okay, and we have this one is IF, and this one is the armature current IA. IF is I field, and this one is your I supply. Okay, so this is in the circuit form, it is represent like this. So this is what we call a shunt DC motor. Okay. For a separately excited DC motor, meaning that the circuit, armature circuit, we have RA and then LA, and then we have back EMF, which is EA, and then we have here is VA, V armature. So this current is IA. It is actually the field circuit RF and LF is supplied by separate source. Okay, meaning that you have two supply. For example, this one is connected, so meaning that this one is supplied by another source. So there are two sources. So under separate excited DC motor, so it is the armature circuit and the field circuit are separate. Okay, but in terms of the performance, in terms of their characteristic, these two motor are actually produce the same performance and also same characteristic. Okay. Okay, so from this one, okay, we have RF and LF, RA and LA. So actually RF and L actually represent, okay, these two and these two actually represent the winding and internal resistance of the cables. Okay, because inside that you are actually you wind up, right? The cables you wind. So actually the winding itself will produce inductance. It's actually a solenoid, right? Because inductance is a solenoid. So once you use winding a cables, it will produce inductance. And the RF is actually the internal resistance of the field winding itself. And RA and also LA, same. Okay, it actually represent the winding. But okay, for a steady state operation, okay, for a steady state operation, meaning that all are constant, meaning that there is no change of speed, there is no change of currents, and so on. You will see that actually if there is no change of current, for example, di over dt, meaning that it is zero, right? So we know that the voltage across this element is, for example, the inductor, okay, VL is L di dt, right? But since there is no change, meaning that in a steady state operation, meaning that the speed is constant, okay, all the day. So this one is zero, right? So there is no change. So VL is zero. So meaning that for our analysis for the steady state operation, we can ignore this inductor. So meaning that we have only RF and also RA only. Okay. For steady state operation. Okay, there is no L inside here. Okay. Any question? Okay, so if there is no question, then okay, I think if okay, then we move to the equation. Okay, the equation. So we have the field winding. Okay, the equation. At this point, I think okay, I just use RF. Okay, and then my VT here. Okay, and then we have RA, and then EA. Okay, so this one is IA, this one is IF, this one is your IT ke I source, it depends lah. Okay, okay. So right now the motor is actually transforming from electrical power or energy, electrical energy, into a mechanical energy. So for electrical energy, what is the parameters? What is the important parameter for electrical energy? Electrical. What is the parameters? Mean that the parameters. No. Meaning that the okay. The important parameters for electrical inside the electrical is the voltage, right? Voltage and what is the important? Yes, yeah, current. Voltage and current. And for the mechanical energy, what is the parameters that usually we want for the mechanical usually? Yes, the speed, which is omega here, can be in RPM, rotation per minute. Okay, RPM is actually rotation per minute, or sometimes also in radian per second. Okay, or the speed. And what are the parameters? The second parameter for the mechanical. Yeah, rotation speed. Okay, and then one more. Yes, torque in Newton meter. And there are another one which is a position. Okay, position. This one usually for stepper motor. Okay, for example, the laser, this laser. So it requires the motor to have a precise position to read all the data. But for this syllabus, so we just ignore the position. Okay, so our main tag is actually main parameters that we want to see is actually the relationship between electrical energy and mechanical energy. In electrical energy, we only focus on the voltage. All the calculation must be in the voltage, current, okay? And for the mechanical energy, is different. So it is more towards on the speed, the characteristic of the speed, and also the characteristic of the torque. Same, since this is electrical energy, this one mechanical, so usually we use the same units lah, kilowatt hour, okay? It's different for the combustion. Okay, for the heating, we are using calories. Okay, we are using calories. For I think for mechanical and electrical, we are using the same units for the calculation of the energy. Okay, so the relationship between electrical energy and mechanical energy for the DC motor is quite simple, straightforward. The voltage is proportionally with the speed, and the current is also proportional with the torque. Meaning that if you want to increase the speed, you need to increase the voltage. Same with this one. If you want to increase the torque, you need to increase the current. It's a proportional. Okay? So that's why sometimes if you have, for example, what I call 12 volt 12 volt DC motor, your remote car, you have sini battery, 12 volt batteries. So okay, so when you turn on this switch 12 volt, you will see that the speed of the motor is rotating very fast. But when you connect your, for example, the tire, okay, a tire, the very heavy remote controller vehicle tire, okay, suddenly when you connect the tire into the shaft, the rotation will be slower. But when you disconnect this load, okay, this tire we can consider a load for the motor. So when you disconnect the tire, it rotate faster again. But when you connect the tire to the motor, it rotates very slow. Okay, because why? Because the torque is not enough to produce, okay, to rotate the very heavy load. Okay, in order to accelerate or to make the rotation faster, you need to increase the current. The current need to be increased. So that's why when you can see that when you are actually driving a motorcycle or you're driving a car, you want to accelerate. Okay, if you want to accelerate, you need to have a more torque, right? More torque, more force. So in electrical car, it is the same. If you want to have more torque, okay, you need to have more current from the battery. Okay. So okay, one of your friend also asked me, what type of motor used for the electric vehicle? Okay. So actually, the motor used for the electric vehicle is a three-phase induction motor. Okay, three-phase induction motor, and some of the, I think Tesla use a three-phase BLDC motor, if not mistaken. It depends on the model. Okay, but we use mostly, I think, for the current electric vehicle, use a three-phase induction motor. Okay, in 2011, I'm actually heading a team of UTM. We are, and with the students, undergraduate students, we are actually converting Proton Saga BLDM from the Saga Proton into electric vehicle. Okay, in 1 year. Okay, we convert all the engine, we move it, and then we install with the electric vehicle, electric motor itself, three-phase induction motor, and then inside the bonnet, under the bonnet, the back bonnet, so we install with a lithium-ion battery. I think lithium-ion battery is an 80 volts lithium ion, okay, at the back. So lithium ion is a very lightweight battery lah. Okay. Okay, so let's move toward this one. So electrical energy and then the current torque here. So the important parameters is actually torque and speed. What is the relationship? I think torque is actually, as you can see, is proportional with IA. Okay, the torque produced is proportional with armature current. So we can see this is a proportional, meaning that you have a constant flux IA. Or sometimes also T is equals to K. There are two KT and K flux, and this one is IF and IA. because actually flux that produce inside the field circuit, okay, IF is proportional with the flux produced. So that's why you can use this, or also you can extract. So it's expand like this. So this one is actually flux. Okay. Okay. And then another one is actually EA. So the back EMF. This one is what we call back EMF, electromagnetic force. This is the voltage that produced due to the rotation of the motor. So since because of that, okay, it is automatically generated. Okay, is actually K speed multiplied with the flux and the speed. So it is proportional. So if the speed is increased, the voltage produced by this speed is also increased. Okay, or sometimes EA is KW, K flux, IF. This one. Okay. And the other parameters is actually based on the basic electrical circuits lah. So this one is VT. So we know that VT is equals to IARA plus EA. Okay, and so on. For example, and for this one also, we know that VT is also is equals to IF RF. So this one is actually what called the armature equation, and this one is the field equation. So this one is actually a basic equations lah. You get that you can derive from the basic Ohm's law, right? But the important parameters is this one. You need to know this and this. Okay. So I think I want to proceed with the examples. So I think we take a break about 5 minutes. Okay. So at 3 p.m. So we will continue our class with the examples. One example only. Okay. So right now it's 2:55. So we meet again at 3. So you can exit this room first to save your, I think 10 minutes lah, 10 minutes. So at 3:05 p.m., 3:05 p.m. So we will continue back. Okay, so you can exit this room. And then once I ready, so I can inform through the WhatsApp group, and yeah, you can join the class back. Okay, so I leave this room on. Okay, for those who want to exit first, you can exit. Okay, so meet again at around 3:05 p.m. Okay. Okay, Assalamualaikum. So we meet again. Okay. So as you can see here, we have torque. Okay. Equation of the torque, which is equals to K flux IA, or sometimes also you can write it down as a K T and K flux IF IA. Okay. Which is actually this one is actually flux actually. Okay. And you have also the power developed by the mechanical energy, okay, which is the power in mechanical energy you can compute by using this one is the speed in radian per second, and this is a torque which is in Newton meter. Okay, so the unit is still watt. Okay, or also you can also calculated the power developed by the mechanical energy by using the voltage back EMF Okay, so this is back EMF multiply with the armature current. Okay, so this is interchangeable, meaning that speed multiplied with torque is equals to EA. Okay, this one is actually from electrical part. From the electrical, this one you can calculate your power from mechanical. So actually, we'll give you the same answer. Okay. So this is also very important. You need to know these equations. Okay. Also this one. So right now you have 4 equations. Okay. The first one is torque, which is K flux IA, and then EA, which is K flux speed, and then the second one is the third one is this one, the P mechanical uh, speed multiplied with torque, or in P electrical, which is EA multiplied with I. So actually P mechanical is actually equals to P electrical. Okay. And the power rating. So what you should know about the power rating? So power rating of the motor, sometimes it said 5 horsepower. So mean that this is the motor that the motor can run safely, okay, in a continuous basis. Meaning that it is a continuous, meaning that all day it can run at that value speed. Okay, so that is the what you refer to. Okay, power rating. Okay, and then this is the efficiency. I think this is a very general form of the equation of the efficiency, P out over P in. And we have also another parameters, what we call the speed regulation. Okay, so the speed regulation, which is no load speed minus the full load speed over the full load speed. This one also, I think, very important. Okay, speed regulation. For a good motor, so the difference between no load and full load is very minimum. So that is a good motor. Okay. Okay, so this is the magnetization curve, which is the relationship between the EA versus the field current, okay, for a given speed. So this is the curve for when it is n is equals to 1200 RPM. So for a different speed, you will have a different curve. Okay, so this one is usually will actually to get this you know that EA is equals to K flux speed, right? And usually also can be written as a EA is equals to K as multiply with K flux. So this one is K flux IF. Okay, so this one is actually you can get EA over IF. This one is actually to get uh, these parameters actually. These two parameters. Okay. Usually this magnetization curve is used to get this constant. Okay. These two constant. Okay. Oh, okay. I don't know whether I have. Oh, okay. So this is one example. The machine having the magnetization curve shown in figure 16.15 is operating as a motor. Okay, is operating as a motor at a speed of 800 RPM with IA is equals to 30 amperes and IF is 2.5 amperes. The armature resistance is 0.3 and the field resistance is 50 ohm. Okay, find the voltage VF applied to the field circuit and the voltage terminal applied to the armature circuit. So right now we don't know what type of motor is it, but I think it is not very important because it has given you the value of IA and also IF. Okay, so to get the VF, so it's very simple because we know the field circuit is like this. V is actually a very simple circuit, right? So just a VF and then you have only RF, right? So this one is your IF. So from here, you can compute directly your field voltage. Okay, the voltage required to supply the current of IF 2.5. So the required voltage field is 125 volt. Okay. Next is to get the VA. So I think this one or VT. Okay, but it's quite complicated here. Okay, because the information given here is the curve when the speed is 1200 rpm. Okay, but the question given here, the information from the question is it give you the values of 800 rpm. Okay, this one, the motor is actually speeding at 800 rpm. So what you need to do is just to use the relationship, because we know that the constant is actually is a fixed values. So we can use that information to get the values of the voltage EA, okay, induced when the speed at 800 rpm. So what you need to do is just to use the ratio here. We know that for the speed of 1200 rpm, the voltage induced at the back EMF value is 145. Okay, so by using this formula here, this relationship, okay, we can calculate the voltage EA or back EMF during 800 rpm. So based on this one, the values of the voltage back EMF at 800 rpm is around 96.7 volt. Okay, then from that you use the armature circuit. We know that the armature circuit is this one, VT or VA. So we have RA and EA here. So you use the KVL, and IA is given 30 amperes. RA is also given 0.3, and EA you have already obtained 96.7. From that you can calculate the voltage terminal is around 105.7 volt. Okay. This one, it didn't mention about separately excited or shunt or something else. But it give you this information. So this information is enough for us to do the calculation. But from here, from the solution here, what we can conclude that it looks like it is a separately excited DC motor, because the VF values is different. VF 125 and the voltage terminal armature here is 105.7. Okay. Okay, and then the developed torque. So the developed torque is actually from this one, K flux IA, right? So the IA is 30 amperes, but this one, IA is given 30, but we don't know this one. the K flux, which is you can calculate your K flux based on these values. Okay, the given, which is this one. We know that EA is equals to K flux speed, right? And the EA here is 145 volts over the speed is 1200 RPM. You need to convert into radian per second. So to convert into radian per second is 2 pi over 60. So you will obtain your K flux, okay, is equals to 115. Okay, so that's why we have here. And then we substitute this one. So we obtain that the torque developed is 34.5 Newton meter. And for the power mechanical developed is you just multiply the torque multiply with the speed. But the speed is this one is RPM. So you need to convert into radian per second. So you need to multiply 2 pi over 60. So you will obtain the values is 2.89 kilowatt. Okay, I think I stop here for the example. Okay, so for our next class, which is on Wednesday, so we will discuss more on the second example. Okay, I think the time is not right. Okay, it still is. I think maybe not focus most of you because this one requires some focus. Okay. So, but I want to. Okay, this one actually. Because I want to highlight something, a very important one. Stop sharing. Okay. For a shunt motor or a separate excited DC motor, okay, you will have the torque speed characteristic. So this one is a very important for any motor, torque speed characteristic. So this is your torque and this is your speed. Okay. So based on the equations, I think we will discuss later. I think on Wednesday, you will have this linear. Okay. Sorry for my bad drawing. This is a straight line. Okay, straight line. This is the speed 0 radian per second, and this is the speed. This is the speed. This is no load speed. Sorry. No load torque. Okay, and this is your. Okay, so this is the characteristic, okay, of a DC motor. So this one is for shunt DC motor. Okay, for shunt DC motor. So how to determine, for example, you have a DC, you have, for example, a shunt DC motor, okay, you have a drive shaft here, and then you supply with a voltage supply, so maybe for example 100 volt, okay, and then you supply, and then you connect a tire here, okay, a tire, okay, a tire. This tire weight is maybe equivalent to maybe 30 Newton meter weight. How can you determine the speed of the motor? How can you determine the speed of the motor? Okay, it's very easy because this weight is actually a time independent load. So this value is actually uh not time independent. It's actually a speed independent. So meaning that it is a constant torque load. Okay, constant. The weight is a constant, right? 30 Newton meter. So at any speed, the torque, the load is still the same. The weight is still the same, 30 Newton meter. So if you plot, so this one is the torque speed characteristic of the motor. If you plot the torque load line, which is this one is 30 Newton meter, the intersection between torque load and the motor speed characteristic will give you the value of the speed of the motor. Okay. So that is how we determine the speed of the motor. Some of the load maybe have this kind of torque load. It depends on the load. This is maybe torque load number 2. Okay, this is for example is equals to fan. Okay, so depends on the intersection, so it will give you the value of the speed. So the intersection between the torque speed characteristic of the motor and the torque load will give you the value of the speed. Okay, so I think that's all from me today. Inshallah, we will meet again on Wednesday. So we continue on examples, second examples, and also the controls of the DC motor. Okay. I think that's all from me. Thank you very much.
Thank you, Brother.
Okay.
Thank you, Doctor.